Hey folks, it's Toby Vance here from Darwin's PITBULL. This is our video on factual evidence for evolution part 3. This is part 3 in our series, and today's video is going to be about the human fossil sequence. So we're going to be talking a little about paleoanthropology and the evidence that we see in the fossil record that supports human evolution. So follow me on over into the presentation. Let's get started. Okay, so today we're talking about human fossil sequences. As you can see here in our chart, we have a whole variety of both human and pre-human fossils that have been found and roughly where they show up in the fossil lineage. You can see Australopithecus afarensis, 3.9 to 3 million years ago. You can see South Asian Homo erectus at 1.6 million years ago. You can see Neanderthal here, roughly 400,000 years ago. You can see North Asian archaic and modern Homo sapiens, African archaic and modern Homo sapiens. So we've got all of these different fossils represented. One of the objections we hear from creationists constantly is that we have a missing link, or we don't have an incomplete fossil sequence for human evolution. But that is just not true. We have an entire variety of fossils that exist that show a progression from earlier ape-like primates to modern humans. And we have a progressively consistent fossil lineage that shows that and shows that clearly. So that's what we're going to look at today. We won't be looking at every single one of these fossils, but we're going to look at some of the key ones and show how they do show this progression. So let's take a look at the first one we're going to look at, and that's Australopithecus afarensis. Australopithecus afarensis is considered to be an ancestor of ours. You can see here that Australopithecus afarensis existed roughly between 3.9 and 3 million years ago. We have a cranial capacity, which is essentially the size of the skull and the brain case. That would be from 375 to 550 cubic centimeters. We have this fossil here, which is one of the most complete fossils of Australopithecus afarensis that has been found, called Lucy. Lucy was found by the anthropologist Donald Johanson in 1974. And because the fossil is pretty complete, we have a pelvis, we have some leg bones, we have a rib cage, we have arm bones, and we have a jawbone and parts of the skull. Because we have a pelvis gives us a very good indicator of whether this species walked upright. Now, we constantly hear creationists say things like Australopithecus was nothing more than an ape, okay, or that the fossils we find are either just fossils of apes or they're fossils of humans. But let's think about that and let's look at the evidence for that. Notice here we have a chart of different pelvises. Okay, and the first one we have here is a chimpanzee pelvis. You can see from the side view that the pelvis is essentially flat and straight. Okay, because the pelvis is straight up like that, the pelvis pushes the upper body forward, which is what causes a chimpanzee to have to walk on all fours. Now, let's look at the Australopithecine pelvis. Okay, it's more like a saddle and curved. Okay, very much like a human pelvis. Here we see the human pelvis. We have what's called a rotated ilium, okay, which is that curved area, much like a saddle that houses essentially the upper body and keeps it upright. Okay, you don't have that in a chimpanzee because a chimpanzee doesn't stand upright. Okay, but we do have that with the Australopithecus, and we also have it with a modern human. So you've got a progression here, okay? You've got something that has a pelvis very much like a human pelvis, which means that Australopithecus walked upright. Okay, this allows for the upper body to sit inside the pelvis, much in the way a person sits in a saddle. Okay, notice this pelvis for the chimpanzee does not allow that. Okay, the human pelvis also allows that. Now notice The human pelvis, it's a little bit further back, so it allows for even straighter, uh, more erect posture. Okay, the Australopithecine pelvis, it's a little bit forward, so there might have been a little bit of slouching forward by an Australopithecus, okay, but not much. They would not have walked on all fours as does a chimpanzee. Now let's move on in the fossil record to what we find next. Next, we have Homo habilis. Okay, Homo habilis is considered to be a species that comes next after Australopithecus afarensis and would have evolved from afarensis. Uh, Homo habilis existed from roughly 2.4 to 1.5 million years ago. Homo habilis, notice the brain case is a little bit bigger now than Australopithecus. It's 500 to 800 cubic centimeters. Homo habilis begins to use rudimentary stone tools that we find in the layers near the fossils of Homo habilis. You notice here the skull has a very pronounced brow ridge. Okay, you see this in all of these examples of Homo habilis skulls we have here. And then the forehead slopes back and the back end of the skull protrudes out further than in a modern human skull. We'll look at a comparison of those skulls in just a moment. So we've got a slightly bigger brain case. We've still got a species that walks upright. We know Homo habilis walked upright, and it comes a little bit later in the fossil record than Australopithecus afarensis. Once we come to Homo erectus, the next in the line of fossil lineages that we have an almost complete fossil of Homo erectus. We call it Turkana boy. His fossil was found on the banks of Lake Turkana in Africa. The layers that Homo erectus has been found in date from 1.8 million to roughly about 300,000 years ago. The cranial capacity is a little bit bigger, 750 to 1,225 cubic centimeters. So it's bigger than Homo habilis. We now have a skull that's slightly bigger and a bigger brain. The body, as you can see, is almost human-like, so we know it walked upright. Okay, its skeleton, what we call postcranial skeleton, that is under the head, is very much like a human's, only smaller. We have evidence that Homo erectus began using fire and also stone tools. Now, if you look at the erectus skull, it looks very similar to a Homo habilis skull. Very pronounced brow ridge, sloping forehead, only the skull is quite a bit bigger than Homo habilis, as we see here with the brain capacity. We move on and we come to what we call archaic Homo sapiens. That's the earliest forms of our own species, Homo sapiens. Archaic Homo sapiens fall into layers that date roughly between 500,000 to 200,000 years ago. Average cranium size is 1,200 cubic centimeters. Okay. So this is the average size. You notice probably that Homo erectus had an upper capacity of that, but this is the average for Homo sapiens, so it's slightly bigger than Homo erectus. Still quite a pronounced brow ridge and some sloping of the forehead. The protrusion of the back is beginning to come in quite a bit. Doesn't stick quite as far out as it does in Homo habilis and Homo erectus. Then we move to modern Homo sapiens, what we are. We see almost no brow ridge and the forehead is flat, okay, no sloping at all. We start finding Homo sapiens, modern Homo sapiens in the fossil record roughly about 195,000 years ago on up until the present. Average cranium size is slightly bigger than archaic Homo sapiens at 1350 cubic centimeters. Okay, so we've seen a steady increase in the cranial capacity and the size of the brain. Okay, in the layers around modern Homo sapiens, we find very advanced tools. We find evidence of art. We find little statues. We find evidence of musical instruments. All kinds of more advanced culture, indicating obviously the higher thought processes and higher rational thinking processes of modern Homo sapiens. So let's kind of compare all of these. Now, we didn't really look at Neanderthal, and that's because Neanderthal doesn't fall within our lineage. Neanderthal is more of a cousin to us. Homo erectus evolved into two branches, one which became modern humans and one which became Neanderthals. So we don't come from Neanderthals, although we are related to them indirectly. But they're in this chart, so we'll take a look at them. So let's look at Australopithecus. Remember, the brain size, the cranial capacity was very small, a very thick brow ridge, and a very sloped forehead. Okay, large nose, and the face protrudes forward much like an ape does. So in the face, Australopithecus looked very much like a chimpanzee. However, remember, it walks upright. Homo erectus, we still have the large brow ridge, sloping forehead, face protrudes slightly, not as much as with Australopithecus. Then we get to Cro-Magnon and modern Homo sapiens, modern humans. We have a very large brain case, much larger than Homo erectus and Australopithecus. We have a flat forehead, very little brow ridge. Face is flat, it doesn't protrude. Chin is much stronger than it is in these species. Okay, so these are all very different species. These are not just variations of apes or humans. Okay, there's a sequence here, there's a progression here. So let's look at this chart again. This is a different chart showing some of the fossils and where they fall in the sequence of the human lineage. But let's take a look here. Here is Australopithecus afarensis. Okay, notice we only find fossils in these layers, which are roughly about 3.8 to about 3 million years ago. Don't find any afarensis fossils up here. We don't find any afarensis fossils back here. Okay, let's look at Homo habilis here. Here's Homo habilis in the range here. Okay, we do have kind of a gap. We found a fossil here, but we haven't found anything in between. So it's likely that we can push it back this far to, say, 2.3, 2.4 million years ago. Okay, but because we have that gap, we don't have evidence for that, but we can assume that Homo habilis existed in this gap period. And we have Homo habilis fossils all the way up to about 1.5 million years ago. Now, Homo habilis only falls in this range. We don't have any up here closer to our own time period. We don't find any back here prior to afarensis. Okay. Then we've got Homo erectus. Homo erectus survived for quite a long period of time, almost 2 million years ago, all the way up to almost about 300,000 years ago. We find them all along in that range. We don't find any prior to that. We don't find any since their extinction. And notice roughly about the time they go extinct, we get Neanderthal and we get modern humans. We don't find any modern human skulls anywhere prior to this point in time. We don't find them back here with afarensis. We don't find them here with africanus. We don't find them here with Homo habilis or Homo erectus, okay, which is exactly what we would expect with evolution. We shouldn't find these fossils together because they evolved from each other. Now, because of the fact that there are characteristics which put them transitionally between humans and apes, it's sometimes very hard to classify where some of these species go because they do contain characteristics of both. Now, creationists like to make the claim that all of these fossils are nothing more than just apes, or they're just humans, more primitive style humans. But looking at this chart, these are prominent creationists, and looking at some of these fossils that I just showed you in the pictures, you can see that even creationists don't agree on what they are. Here with ER 1813, which we showed previously, most creationists put that in the ape category. However, one puts it in the human. Java man, who is a Homo erectus, we got about half putting him in an ape and about half putting him as a human. Peking man, which is also a Homo erectus, the same. We got a little less than half putting him as an ape and a little bit more than half putting him as a human. We can go through the sequence here and see that there is no agreement even among creationists on where they fall. Okay, again, with evolution, that's exactly what we would predict. We should predict that as the species evolves, it's going to have characteristics in some cases which are very similar to human, and in some cases which are very similar to ape, which can make them very hard to classify. Even among evolutionary anthropologists, we have difficulty many times categorizing them because of this similarity in characteristics. So we see here even that creationists have many disagreements. So in conclusion, we can see that creationism has no explanation for all of these fossils and what they are. They try to explain them either as apes or humans, but we see that doesn't fit the facts. We have a progression of much smaller skulls to larger skulls. If creationism is true, when did all of these creatures live? According to creationism, they must have all lived together, but we don't see any evidence of that in the fossil record. We see them uh, very segregated in the fossil record, and fossils are never together in the same layers. Okay, creationists try and claim that fossils are the result of um, the flood of Genesis. But if the flood of Genesis occurred and these things got buried, why did they not get buried together? Why do we not find a human fossil buried next to an Australopithecus fossil? Why are they so segregated? Segregation of these fossil sequences is exactly what evolution predicts. It shouldn't be what creationism predicts. Creationism should predict that they're all together if they all live together at the same time. But we don't see that in the fossil sequence. We see that they are arranged in an orderly procession from smaller, more ape-like to larger, more human-like. And we can see that we have multiple fossils that show us that progression. Far from the fact that we're missing fossils and don't have transitional fossils as creationists try to claim, we actually have multitudes of fossils, and we have a very orderly sequence of evolutionary progress that shows up in the fossil record and shows us without any shadow of a doubt that evolution, particularly human evolution, occurred.